All right, so today, because I am not here, I wanted to leave behind a little screencast video for the notes. You guys are going to use your note packet that you picked up at the door today and follow along, fill in the blanks. And I'm going to go over some sample problems with you guys so that you're able to do the homework book assignment that you have for tonight, which is the first assignment on your unit calendar. And today we're beginning a brand new unit on chemical nomenclature. And what chemical nomenclature is, it's a way to name all the different chemical compounds that you'll be seeing in chemistry. And to begin, we're going to take a look at the periodic table. And the main things that you guys want to see here is that your periodic table is arranged so that you have your metals over on the left side of the table, and the nonmetals are found on the right side of the table. And when I say left and right side, we talk about the metals being on the left side of the stair step. These are some of the characteristics here that you guys could copy down into your notes. You could pound them into a shape. They're pulled into a wire. They have a shine to them, the luster, and they're really good at conducting heat and electricity. And here, if you take a look at our periodic table of the elements that you guys have, I would pull out your periodic table and label this with me as well. The staircase, if you look up at the staircase that we have in the room, it runs right between boron and aluminum, and it just goes up and down all the way to down to polonium over here. So this is called our staircase. Go all the way down. And we say things that are to the left side of this periodic table, these are your metals. Things that are over to the right side of your periodic table, we would call these our nonmetals. And if you take a look at your notes, we have this part right over here. And an important word for you guys to remember, along with, let me come back here, we have the metals, you guys have your nonmetals, and we have ions. Okay. And an ion is a very important definition to remember. It's an element that has gained a charge, okay? And if you guys remember, elements or atoms, they have protons in them, they have neutrons in them, and they also have electrons in them as well. And you could easily tell how many electrons an atom would have just by looking at the number of protons. Okay, so an example that I have for you guys right here is our element of sodium, which we know is Na, right? And if you find sodium on our periodic table, it's right over here, we look at our atomic number, which is 11. So we know that sodium has 11 protons, and an atom of sodium also has 11 electrons. Okay, so if you know that you have an atom, the protons and the electrons are always equal to each other in number. Okay, now things get a little more interesting if we're talking about ions. And remember, what an ion is an element that has gained a charge. Okay, we know that they gain a charge by either gaining electrons or losing electrons. And a sodium ion still has 11 protons. Remember, if we change the number of protons, it would actually turn into a different element. So we know that doesn't change. Okay, but the sodium ion actually has one less electron than the atom. So instead of 11 here, we have 10 electrons. Okay, and if you think about that, 11 protons is plus 11. 10 electrons is negative 11. If you guys look at that, plus 11 and negative 10, you end up getting a, this means that there is a positive charge. Oh, I meant to write there is one more positive charge than negative charges. Okay, so if you look at here, we have 11 protons and 10 electrons. So we have one more positive charge than a negative charge. And we would say that it forms a cation. Okay, if something is having a positive charge, right, we always call this ion a cation. And the charge could be dependent upon the element. It could have a positive 2 charge, it might have a positive 3 charge, but we do know that if there's a positive charge, we always are going to be calling it a cation. Okay. Now, nonmetals, we're going to go back to our PowerPoint here. So our nonmetals, if you guys are following along in your notes, we're looking at this part right here that matches up. So nonmetals actually end up gaining electrons. And an example of this would be oxygen. Okay, so our oxygen atom has a total of, if you take a look at our periodic table, we know that there are 8 protons in oxygen. So same thing as what we did before, our oxygen atom would have 8 protons. And because it's an atom, no charge yet, we also have 8 electrons. Okay. Now, an ion of oxygen actually has 8 protons still. Remember, that will not change. Okay. But an oxygen ion actually ends up gaining electrons. So it actually has 2 more electrons than what we had before. So we actually have a total of 10 electrons here. Okay, so in terms of the charge, the atom has 2 more negative charges than positive. Okay, so it forms a -2 ion, and anytime you have an ion that has a -2 charge, we actually call it an anion. Okay, so we learned 2 new words here. We learned the word cation up here, which means an ion with a positive charge. And we also learned the word anion here. It looks like onion, but it's anion, which is something that has a -2 charge. And to finish this off, the oxygen actually gets a brand new name to it when you add a negative charge on it. Instead of calling it oxygen with the negative charge, it's actually called an oxide. Okay, so we'll talk about this name change later on. And if you guys flip it over to the back side, I'm going to have you guys go back and fill this out according to the PowerPoint. So if you look at the PowerPoint with me, okay, we're down over here. Oops. Okay, so ion arrangement on the periodic table. So for the group A metals, your charge is always equal to your column number. And if you guys take a look at your periodic table that you all got, good idea to start labeling these here. My A metals are right over here. So I have 1A, I have my 2A, right? And our charge is always equal to the column number. So these guys all have a charge of +1. These guys all have a charge of +2. Okay, so that's what that means there. Now for our group A nonmetals, your charge is actually equal to whatever the column number is -8. Okay, so if you guys remember, the nonmetals are over on the right side of our periodic table. So let me show you guys the periodic table again. And these guys to the right of my staircase, these are my nonmetals. So it says here that we take a look at the column number. So if you look at the 8A, the 7A, the 6A, the 5A, the 4A, and the 3A, right? And we say that the charges for all these nonmetals here are going to be your column number -8. So if we look at start here, 8 minus 8 means a charge of 0. And if you remember, these are noble gases. They actually do not form an ionic compound. They don't form into ions. And these guys over here, our halogens, our number is 7, so we do 7 minus 8, and we end up getting a charge of -1. Okay. These guys over here, it's 6 minus 8, so we get a charge of -2. These guys here, we have 5 minus 8, so we get a charge of -3, right? And the carbon and silicon we're not going to worry about. So if you just remember, it's going backwards. It's 0, -1, -2, -3 here, and that's where that comes from. And we also have B group elements, and these metals here are called transition metals, and it includes the middle elements on the periodic table along with a few of the neighbors that we're going to be talking about. And if you guys could copy this part here, some of these metals have more than one kind of positive charge. Okay, almost all of them has a +2 charge and at least one other charge. And silver and zinc are the exceptions. Silver always has a positive charge and zinc always has a +2. And the other metals have a Roman numeral after them to identify the charge. So let me come back to the periodic table. If you guys are looking here at your periodic table, If you look carefully right here, this starts off by the B's. So we have 3B, 4B, 5B, 6B. So all of these guys in the middle right here, we call these transition metals, and they're also called B group elements. So these are your B group elements, and another name for this is also your transition metals. Okay, so before earlier, we had the periodic table mapped out. Like we said, lithium, sodium, potassium, rubidium, they're always going to have a positive 1 charge. These guys here always have a positive 2 charge. These guys on the right side, that's 0, -1, -2, -3. So if I told you I have an ion of sulfur, I could say, oh, that has a -2 charge. But the guys in the middle here, the transition metals, the B group elements, these guys, we don't know their charge just by finding their place on the periodic table. There is no set of rules here. Iron, sometimes it could have a positive 2 charge. Sometimes it could have a positive 3 charge. Okay, we don't know. So there's more than one type of charge that it could form. And in the notes, I did give you an exception. Write this down in your periodic table. Silver always will have a positive 1 charge. Zinc will always have a positive 2 charge. And aluminum, I like to think of it like 1, 2, 3. Aluminum is a metal because it's on the left side of this staircase, and aluminum always will have a positive 3 charge. And you could also figure that out because it's in group 3 and it's a metal, so it's going to have a positive 3. But other things here like iron or cobalt or nickel or copper, right? These guys here, you need to give a Roman numeral to the name. So let's add that in too. And the Roman numeral is going to tell you what the charge is. For example, if I told you I have chromium 2, okay, the Roman numeral here means that this chromium has a positive 2 charge. I could also say I have chromium 3, and that 3 indicates that this is a positive 3 charge. So some of these guys in the middle, the transition metals, they need to have a Roman numeral in the name, and that's what that was going over in the notes in the PowerPoint right there. Okay. All right, and you guys are going to copy up to the part where it says polyatomic ions right here, and that's it in terms of the notes. I'm going to have you guys work on an assignment that I'll be posting up on Google Classroom as well. So once you guys are done with this, you guys could answer those questions and then go back and listen to anything that you need to again, and that's all.